Welcome. Thank you for joining me for section 2.5. Today we're going to dive into a section on using linear models. So here we're going to be looking at some real data and we're going to make some linear models to represent that data and then to make predictions about that data. So one of the big ideas we're going to talk about today is a scatter plot. Okay, so scatter plot, all it means is a graph that relates two sets of data by plotting the data as ordered pairs. So when we talk about correlation is going to be the strength of the relationship between data sets. The closer the points fall along a line, the stronger the correlation between the two variables. Now, so we're going to learn how to describe correlation as strong or weak and positive or negative. So for example here, this is a strong negative correlation. Because if you notice, if you were to sketch in the line, it would have a negative slope. And the points are falling relatively near the line, so we're going to call that a strong relationship. This one with the points a little bit more scattered, we're going to call that a weaker negative correlation. If you can't see a pattern at all, that's going to be no correlation. This one switches. Now when you kind of sketch a line to represent the data, now that line has a positive slope. So we're going to say that is a weak positive correlation. And then this one is getting a little bit stronger, so we can call that a strong positive correlation. All right, so when looking at this data, okay, the thing that I want us to get accustomed to is using technology to help us with looking at the data, okay? So for this lesson, you definitely need your graphing calculator out because it's going to be very, very beneficial to you to be typing all of these in with me so you start learning the keystroke commands for these. So I'm going to take this data, and this table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot, and how would you describe the correlation? All right, so I'm going to call the average temperature the X, and I'm going to call the electricity bill my Y value. So each of these are a pair of points. So for example, January has an X of 61 and a Y of 150, okay? And then we're going to continue on, and this is going to be the same thing, right? It's just continuing that same list. So how can we use technology to help us make this scatter plot? So if you go to your calculator, to make a scatter plot, first we need to go into stats, okay? We're using some statistics here. So it's going to be the stat command, then go into edit. When you go into edit, you now are going to see lists, okay? And we're going to list all of those X values in list 1, all of the Y values in list 2, okay? So I'm going to run through this. So 61, 58, 67, 75, 79, 83, 84, 85, 81, 76, 65, 58. So there's all my X values in order. Then I have to do the same thing with all those Y values and make sure that they stay in order. Okay, 150, 139, 172, 205, 205, 170, 234, 255, 245, 210, 183, 132, 110. All right, so you want to get both lists complete, okay? X is in list 1, Y values in list 2, all right? Now, once you do that and you want to make a scatter plot, okay, so you know for regular graphing, we use that Y equals command, okay? Well, if you look right above it, stat plot, it would go for any statistical graphing. So you kind of go to the same place, but instead of Y equals, you're going into stat plot. And to get to stat plot, you just hit second y equals. All right, so now we're going to go into the first one by hitting enter. Here, I'll erase those. So we need to turn it on first. Here, it's already set to a scatter plot for me. Then here it's pulling all my x's from list 1, y's from list 2, which is exactly how we organized it. So I'm almost ready to graph. The only other thing is I need to adjust my window, okay? Now the cool thing is there's a really easy way to do that. If you go into zoom, notice this zoom 9 is called zoom stat, okay? That's the one that we're going to use because then the calculator will set the window for us, okay? So just hit zoom 9 and you'll be able to see our data, okay? There it is, all nicely laid out for us. So now the question is, now that we can see that data, the question is what kind of relationship could we use to describe this, okay? So looking at this, I would say definitely notice the trend is increasing, right? So because a trend is generally increasing, that would be a positive slope. And I'd say this is relatively strong. Okay, you can see a pretty good relationship happening here. So if I had to describe it, I would say a strong positive correlation. All right, so first step done. Okay, we have our scatter plot. But there's a lot more to it than just a scatter plot. We want some numerical ways to describe this data and relate this data. And that's what the line of best fit is. It's the line that best approximates the relationship between the variables or data sets of a scatter plot. This line can be used to make predictions from the data. All right, so the calculator can also do this for us, which is awesome. Okay, so if I wanted to create the line of best fit for me, here I'm going to erase that. I'm going to go back into stat, and this time I'm having it do a calculation for me. Okay, and I'm going to go down to linear regression. We are performing a linear regression to make the line of best fit. Okay. And here it's pulling my x's from list 1, y's from list 2. So I'm just going to calculate this now. And there it is. Okay, now obviously you don't have to write down every single number here. So let's go back. And so notice the form, y equals ax plus b. So my a is about 4.15. So that's telling me my slope is 4.15. So if I'm going to write the equation of the line of best fit, 4.14x, and then this is going to be my b, my y-intercept. So negative 117.68. All right, so that is my line of best fit. Okay, so let's take a look at what else can we do with this. Okay, so first of all, interpreting the slope. All right, well, the slope of this line is the 4.14. Okay, we know that. But what does it mean? Okay, we're talking about average temperature and electricity bill. So what is our 4.14 telling us? Well, basically what it's saying is for every increase in 1 degree, so every increase of 1x, so every time x goes up by 1, what's happening? The average electricity bill goes up by 114. Okay, so basically it's that whole rise over run effect. For every increase of 1x is telling you how much your y is increasing by. In this case, y is talking about your electricity bill. All right, so for every one of these, we are going to be interpreting that slope. What is it telling us about our situation? So here, every increase in temperature will make our electricity bill go up by 414. What about predicting? Okay, what about predicting when I have an average temp of 90? So for this, I can just plug that in. 4.14 times 90 minus 117.68. Okay, so this is something that the calculator, or that we can actually just plug into the calculator. So I'm going to take 4.14 times 90 minus 117.68, and my average bill is going to be $254.92. So I can also make predictions using this line. Okay, make predictions beyond the values that I have. Now, the final thing we're going to do for each of these is we're going to discuss how to describe the correlation, okay? And here it says, let R help you. Now, R is something, it didn't show up yet because we have to tell the calculator to make it show up. So what I'm about to show you is a one-time fix, okay? Go into catalog, and if you hit the green D, you're looking for something called diagnostic on. Okay, so scroll down, and if you hit enter, it'll just say done. Now notice what happens when I do that same linear regression. Okay, so notice now it's giving me some extra information. Okay, and this R value is that extra information that I want. Okay, so my R is about 0.91. Okay, now let's have a quick conversation about that R value and what it's telling us. So R is called the correlation coefficient, okay? And it measures the strength of the data. R is always between -1 and +1. It's stronger as it gets closer to -1 or 1. Okay, so when it's near 0, that's indicating no relationship, and it strengthens as it gets closer to 1 or -1. If it's negative, it means there's a negative correlation. If it's positive, it means that there is a positive correlation. So the fact that we're talking about 0.91, that is very close to +1, okay? So not only is it positive, we're going to say this is strong. So this is a strong positive correlation. And there you go. So there's quite a few steps, but once you get in the habit of doing this, honestly, most of it is done by the calculator. Okay, so now let's look at this data. So the table shows the median home prices in Florida. What is the equation of the line of best fit that models relationship between time and home prices? Use the equation to predict the median home price in 2020. Start with x equals 0 representing 1940. All right, so what does this last bit mean? What that last bit means, instead of using 1940, 1950, 1960, they're saying use an x of 0. Here, 10 years later, 20 years later, 30 years later, 40, 50, 60, okay? So the year's my x, median price is my y, and now we can go over to the calculator, and if we're being asked to analyze this data, we're going to have to go into our lists, go edit them. Now, to easily clear your list, let's say there's already a list there that you don't want. To easily clear it, go up, hit clear, enter, and it'll disappear. Hit clear, enter, it'll disappear, okay? Now, I'm going to pause the video really quickly so I can input the data. I want you to input the data just the same, okay? So, pause it for a second, input the data, and I'm about to do the same. All right, so I have all my data in. Now I'm going to go and I'm going to make that line of best fit. So remember, to make the line of best fit, you go back into Stat, over to Calculate, and then we're going to do a linear regression. And now notice my R and everything is automatically showing, okay? So that's just a one-time fix you have to do. So again, this is going to be my slope. So when I write this, y equals 1,411.43 x. And then this right here is my y-intercept. So 25114.29. Okay, so you just want to jot down what that equation is. And now we're going to interpret the slope, okay? And again, here, x is representing years. So basically, each year, the house prices increase by, well, they increase by the slope. So this amount right here, the 1,411.43. Because for an increase in 1x, so every 1 year, how much is y changing? The price? The price goes up by that slope, $1,411.43. All right, now to make our prediction. So they wanted to predict the median price in 2020. Well, here, if we let 1940 be 0, this 2020 is 80 years later, okay? So you also want to be careful of that since we started with 0 at 1940, then this 2020 is represented with an 80. And once I write that out, now I'm just going to plug it into my calculator and have it do that calculating for me. And I am getting about $138,028.69. Then the final piece, what about R? Okay, so my correlation coefficient this time is about 0.98. All right, so super strong, right? This is even stronger than the last one and still positive. So this is a strong positive correlation. All right, so let's try it again. All right, so computer use and test scores. Let's see if there is a relationship there. So of course, go into your calculator. I'll erase all of this. Go into your list, clear them out, input the new data. I'm going to pause the video again for a second so you don't have to sit here and just watch me type it in, but I do want you doing this along with me. All right, so now that we have this done, we have all the data in our list. Now we go back into Stat, over to Calc, down to Linear Regression. And here is our new information. All right, so our slope this time is about negative 7.91. So I'm going to go write that in. Y equals negative 7.91x. And then our y-intercept, 98.05. So what is this telling us? Well, for every x, so for every hour online, what happens to the y value? What happened to their test score? Well, their test score went down decreases by 7.91%. Okay, their expected test score decreases by 7.91% for every hour that they're online. All right. Now, let's predict, what about someone who was online for 6 hours? All right, so let's plug that in. Let's plug in the 6. And then, of course, let's type that into the calculator to see. So negative 7.91 times 6 plus 98.05. So someone that spends 6 hours online is only expected to get about a 50.59% on their test. Now, what about the correlation? So our R value, negative 9.0. Oh, sorry, negative 0.90. I apologize. So this time, this is telling me that it is a negative correlation, okay? The negative sign tells me it's a negative, pretty close to -1, so we're going to call it strong correlation still. Now, there's one more that I want to talk about just to make sure we're getting in these good habits. So here, once again, we have this prompt. Let x equals 0 represent 1998. All right, so if this is 0, this would be 2, 4, 6, 8, 10, so on and so forth, okay? So make sure that when you're inputting your data this time, they're using those values. So go back to the calculator, go into your list, and now let's put in this final set of data. So once again, I'll pause the video so you don't have to sit and just watch me type it in. All right, so I have my values in. So now to make that line of best fit, I'm going to go over to calculate, down to my linear regression. And here we go. So our slope, 0.093. So y equals 0.093x. And then my y-intercept is about 2.55. So interpret the slope. So x's are counting the years. So each year, average milk prices for a gallon, what do? They increase by that amount. Increase by $0.093. So they go up about 9 cents every year, according to this model. All right, so what about making a prediction? Well, here, if 1998 was when x is 0, this is 27 years later. So x is going to be 27 in this case. Okay, so 0.093 times 27 plus 255. Type that in the calculator. I get milk prices are going to be about 506. And finally, R, let's go back and look. R is about 0.91. So just like before, that is still very close to 1. So that's a strong positive correlation. All right, so a lot of examples today because I really want to make sure that you get good at the mechanics of this and the technology behind this, but a lot of good stuff. So make sure you write that summary of the highlights you want to remember, the things we discussed, and then make sure you come back ready to do your practice work.